Okay, so in the last two questions, we are supposed to determine the coordinate of a point R in between the two charges that that is a place with electric potential 0, and then we are supposed to answer how much work is needed to bring the electron from infinity to point R. So I'll talk about this one a little bit later, but right now, if point R is per definition a place with a potential equal to 0, that means the amount of work is Q times change in potential, but if this is equal to 0, that means the work is equal to 0. So 0 joules is needed. Remember, we talked about that the meaning of the potential at a given point is really related to the amount of work that we need to do to bring the place from infinity to that particular point. So this is per definition, it's going to be equal to 0. Now let's look at the first question, which is what are the coordinates? So now I know that at that point, the potential at point R will equal to potential due to charge Q1 plus the potential due to charge Q2. Now what is very important is that this is a scalar quantity. So I have to account for the signs, right? And in this case, what I need to do is essentially to say, well, 0 has to equal to K times, right, K times Q1 over R1 plus K times Q2 over R2. Now what I'm going to do is use a little math trick that might be handy for these kind of questions in between. I can express R1 and R2 because I know the difference between the two charges is 0.2. So I know that per definition, my R1 plus R2 will equal to 0.4, and so I know that my R2 equals 0.4 minus R1. So that's one substitution that I will do in this case to solve this equation. And now I'm just gonna plug in the numbers. So in this case, I'll get 0 equals K times, now I know that Q1 is, and this is important, plus 8 times 10 to the power of negative 6 divided by R1, that's my unknown, plus K times, and now this is important, negative 2 times 10 to the power of negative 6 divided by, and in this case I'm going to use 0.4 minus R1. Now this is where it's important to realize that this is why, right? So what I'm going to have here is I'm going to have a positive number minus another number. So this is where I can establish that, and because it's equal to 0, I can say that K plus K times 8 times 10 to the power of negative 6 divided by R1 equals 2 plus K times 2 times power of negative 6 over 0.4 minus R1, right? So this case will cancel out, and if I calculate this properly, R1 is going to equal approximately 0.16 meters away from charge R1. Now this is important to think about here, these signs. Now I want you to understand that if these two charges were both positive, there is absolutely not possible that I find a place where the potential in between would be equal to zero, right? So that is only because one of them is negative indeed. So, right, mathematically, that's why these two equal. If you ignore this sign and you just put them equal and say that's where it is, well, you're not exactly there. You don't really fully understand that concept, right? So why these are equal is because one of them is actually negative. And it can only happen that that zero is in between only if one charge is positive and the other one is negative. Even if they were both negative, there would be no zero in between, right? So it's really, really important. So we know that the point R is 0.16 meters away from this R1 charge.